And I think I mentioned that sometimes you can just show one set of steps. You can go from A to B. And if the steps are reversible, you don't have to worry about going from B to A. Let me back up a little. When I say some expression A is equal to B, right? The way we say this in mathematics, well, I mean, you could just say that. That's one way to write it. Another way to say it would be say, if A, then B. But in the case of equality and identity, it's also, you have to show if B, then A. So on Monday, I pointed out that, well, sometimes when you go from A to B, you can just finish your proof by saying, and the steps are all reversible, right? But one thing you want to be very careful that you don't do is you don't start out assuming A equals B and then just say, you see, I got something okay when I did that. And I'm going to show you what I mean by that. I'm going to show you how to not do an identity proof. All right? So the identity I want to show is that sine of theta over 1 minus cosine theta equals 1 plus cosine theta over sine theta. All right, I want to show that this is correct. So here's how I'm going to do it incorrectly. All right, if A over B equals C over D, then I can cross multiply, right? So I'm going to say sine times sine, that's sine squared theta, equals 1 minus cosine times 1 plus cosine. That's A minus B times A plus B, which is just A squared minus B squared, yeah. Minus cosine squared. But that's just sine squared. So that's good, right? What's wrong with this argument is I started by assuming this was true. Now, in this case, this actually is a valid identity. But there are circumstances where you can start by assuming something is true and show it's true. But it's not. So what's the formal way to do this, right? What's the right way to do this, to show this? Let's start over. We want to show that sine of theta over 1 minus cosine of theta. I'm going to put a little question mark here. We don't know this. That's what we want to show. It's equal to 1 plus cosine theta over sine theta. So how to go about doing this? Well, I'm not going to say how I figured this out yet. We'll get to that in a second. But I'm going to say I'm going to multiply this by 1. Right? I'm going to multiply sine theta over 1 minus cosine theta. I'm going to multiply that by 1 plus cosine theta over 1 plus cosine theta. We would all agree that this is usually 1, and I can multiply something by 1 without changing it. Right? It's the identity property. Okay, so what do I get here? I get sine theta plus sine theta cosine theta. And that's over 1 minus cosine squared theta. That's good. Now I'm going to use my Pythagorean identity here. can draw arrows like this. So now I have sine theta plus sine theta cosine theta over sine squared theta. And now I'm going to reduce, I'm going to divide out a factor of sine theta from both sides, from the top and the bottom. So I get 1 plus cosine theta over sine theta. Well, that's what I wanted to show, right? And furthermore, my steps are reversible. So now I've shown that this equals this, and this equals this. And I've done it properly. Yes?
How did you realize that you need to multiply by 1 plus cosine theta?
Okay, that's exactly what I want to talk about, right? How you figure this out, that doesn't have to be done formally correct. In other words, you can cheat, right? You can do kind of a cross multiply here if you want to see, oh yeah, it kind of worked out, and then figure out how to get from A to B, right? I'm going to give you. I think I'm going to try and show you a strategy to do just that, to figure it out. Right. One strategy is to start on one side. Where am I? Sine theta over minus cosine theta. Start over here, and we'll start over here. Sine theta. And I'm going to work down until I get the same thing. So I look at this and I say, well, the denominator here, I've got cosine, 1 minus cosine, and I have a sine over there. So I need to get the denominator to be sines, right? So how can I do that? Well,
We needed to make it a square somehow.
well, I mean, unfortunately, the obvious thing is what you're asking. How do I figure out is the obvious? If you multiply it by 1 plus cosine theta, it's going to become sine squared theta, right? You see that?
Right.
This is why this Pythagorean substitution is so important. It just comes up all the time. So let's try that. Let's multiply this by 1 plus cosine theta, and this times 1 plus cosine theta. And we get sine theta times 1 plus cosine theta over sine squared theta. Okay. Well, then I might come over here and I might go, well, that's a sine squared. I have to multiply both sides, the top and the bottom, by sine now, right? Sine theta times 1 plus cosine theta over sine theta. Okay. Am I there yet? Yes, right? I worked this down and I worked this down, and they're equal. Now, to make this into a formal proof, you can, we can kind of skip a step here. We say, well, I can go from here to here, and I can go from here to here, and again, my steps are reversible. Usually, it might not be that easy. You might have to take many steps down to here and many down to here. And then, if you want to look a little more obscure and a little more brilliant, then you would rewrite the whole thing on another piece of paper and just go A, B, C, D, E, F, G, H, and the steps are reversible. I know this sounds a little picayune, but this is the way we would do a proof. Right? So, okay, let's see another example. again, the subject matter here is how to verify an identity. All right. The identity I want to verify here is cosecant theta, tangent theta. And I'm, again, putting a question mark here because I don't want to assume this. This is just where I want to get to. Cosine theta, secant squared theta. So I'm going to apply this process I talked about on both sides. First, I'm going to convert this to sines and cosines. By the way, it's not the only way to do it. You know, if you like, you know, tangent, secant, cosecant identities, and you know them, you can do that. But when in doubt, if you're not quite sure, you know, step number one, converting to sines and cosines is usually a good idea. So this is 1 over sine theta. Tangent is sine over cosine theta. Okay, I'm not going to write an equal sign because I don't know this. Here I have cosine theta, 1 over secant. Secant squared is 1 over
Cosine.
cosine squared. Thank you. Okay, let's see here. I can cross these out and get cosine theta. 1 over cosine theta. Here I eliminate a cosine. 1 over cosine theta. Oh, okay. So now these are equal. So now I know my pathway for the proof. I can convert this to this. I can convert this to this. This to this. Multiply, you know, top and bottom by cosine, and then convert to this. It just takes a little planning, that's all. Questions about this strategy?
Oh,
Yes.
this is not the final answer. You have to go through everything.
Well, you know, this is a way to think it through. If you wanted to do a really formal proof that doesn't really show how you got the answer, like the way when I first did this problem up here, you could then say step A, B, C, D, E. You could do it that way. But you could also say, look, this is step A, step B, step C, and then, you know, not really say how I got it, but then, you know, these steps. And of course, you always want to indicate these steps are reversible because I want to get from here to here, and I want to get back.